operation management class. In analyzing the process, we understand the terminology that we call it the bottlenecks. Let's deep down and discuss further about the bottleneck in the bottleneck analysis.
In this video, let's discuss about the bottleneck analysis. The bottleneck analysis is a part of a series of video in capacity analysis. Let's begin by defining what is process time and the component. The system process time, the first terminology that we should know is about the system process time, is the process time of the bottleneck after dividing by number of parallel operation. If we have the bottleneck, process time of the bottleneck is 40 minutes, for example. In the bottleneck is 40 minutes, but they have two parallel operation. So it's mean in this case the system process time is equal to 40 divided by 2, which is 20 minutes. This is the system process time. The system capacity still related with the system process time, is the inverse of the system process time. So the system capacity, I write down in here, system capacity is equal to 1 divided by system process time. So the lower the system process time, the higher the capacity of the system is. This is the implied mean of this definition. And then the process cycle time is the total time through the longest path in the system. If the system has parallel, then we should select which one that has the longest path in the system. Take a look at this example. There is a 3 workstation A, B, and C, which has, in this case, different processing time for each workstation. In here, we can simply understand that the B is the bottleneck. How we can understand the system process time is by the system process time of the bottleneck dividing by number of parallel operation. Since there is no parallel operation, so the system process time is equal to 4. And the system capacity in here is 1 divided by 4. So this is the system capacity, and the process cycle time is equal to 2 plus 4 plus 3, which is equal to 9 minutes. So this is the definition of the process time and its element. Let's take a look further about there is an example of 2 identical sandwich line. As you may see in here, that there is an ordering process. It is due by one person, and then there is 2 parallel for making bread, filling, and toasting. This 3 process is has 2 workers working in parallel. And lastly, we wrap. Wrap is handled by one person. Let's do further analysis for our example case. And then the toast workstation has the longest processing time is equal to 40 seconds, as we see in here. But since there is 2 parallel line, 2 person that in charge for both of this line, so the process time of those combined line is equal to 40 divided by 2. So this is equal to 20 seconds. Since this 2 line in combined is 20 seconds for the process time, so the bottleneck is at the wrapping. and delivery, since this has the longest processing time. The capacity per hour, which is equal to 3600 seconds divided by, so this is 1 hour divided by 37.5, it is equal to 96 sandwich per hour. And the cycle time, so based on the definition of the cycle time, we should follow the longest path. So 30 plus 15 plus 20 plus 40 plus 37.5, which is equal to 142.5 seconds. So actually we pass through the upper line or the lower line is the same. In the bottleneck management, how we can treat the bottleneck. So we should release the work order to the system according to the pace of the bottleneck. So don't rush for the bottleneck. So if we see that the bottleneck is already overwhelmed, we should hold to release the work order. Lost time. This is the implied mean. The lost time at the bottleneck represent the lost time for the whole system. So we need to remember about this. So we need to consider and treat the bottleneck very well, because lost time in the bottleneck equal to lost time for the whole system. And increasing capacity for non-bottlenecks is kind of useless. So we shouldn't consider the increasing the capacity for non-bottleneck first. We should treat the bottleneck first. Increasing the capacity of the bottleneck will automatically increase the capacity of the whole system. Let's use the one method, which is EMV, expected monetary value, and relate with that with the capacity decision. How we can do that? How we can use these tools, to solve the case of capacity. First, we need to determine the state of nature, which is, this is the environment situation, environment condition, such as the future demand or market favorability, whether market will be favorable in the future or not favorable in the future. And then the second, we can use the famous method of decision tree, to determine the capacity decision. For example, supply decision, and then there is an alternative inside it. Let's take a look at the example. We face the decision that we have to choose whether we want to build in the future, of course, large plant, medium plant, and small plant, or we do nothing, which means we don't expand it, we don't build any plant, the new factory, because the demand is already increased. So we face this decision. So in this situation, we already get the survey result from our team that the market in the future is favorable with the probability of 0.4, and market will be unfavorable in the future with probability, of course, 0.6. If the market favorable, we will have the profit of 100,000 if we build the large plant. So this one. But if market unfavorable, we get this minus 90,000. Medium plan is also like that. When market favorable, 60,000 profit. And then medium plan when market unfavorable, minus 10,000. Small plan, we got the small one. When market favorable, 40,000. And when market unfavorable is minus 5,000. And if we do nothing, don't decide to expand our factory, of course we got nothing. 0 in this case. So which decision we should make based on this situation? Here we can calculate the expected monetary value. The expected monetary value of each decision. For example, if we build the large plant in here, we build the large plant, what is the expected monetary value of building the large plant? For example, we can calculate this one by multiply the probability 0.4 multiply by 100,000 in this case plus 0.6 when market is not favorable multiply by this one is minus 90,000. So this is equal with minus 14,000. So with the same way to calculate, we can do the similar calculation for a medium plan and small plan, also do nothing in this case. And then we got the expected monetary value. The highest expected monetary value for our decision is when we build the medium plan. So our decision should be building medium plan. So this is all about the bottleneck analysis, including an additional method, EMV, that we use for capacity decision. See you again in the discussion related with the theory of constraint.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.